So let's just talk about how we can calculate the time complexity of one code. So we're gonna focus on the loops and nested loops to calculate the time complexity. So here we have one C program snippet. So let's now compute the time complexity for single loop. And you can see here we have one single for loop. So the for loop starts from 0 till n and it increments by 1 in every loop. So the loop will run n times, and in each iteration it executes the body of the loop once. So the time complexity of this single loop will be O(n), because here the execution time grows linearly with the size n. Now here we have another loop, but the difference is that here we are incrementing by 1, but here you can see we are incrementing by 2. So because of this, the loop will run n by 2 times, because it will skip every second iteration. But here also we're gonna have the time complexity of O(n), because in big O notation constant factors are always ignored. So we're gonna have the same time complexity for both of these loops. Here if we have incremented by 50 also, in that case also we're gonna have the same time complexity. So let's now analyze the time complexity for nested loops. So here we have two nested loops. So the outer loop runs for n times and the inner loop also runs for n times. So here for each iteration of this outer loop, the inner loop will also run n times. So because of this, here it will have n times n squared times. So the loop will run n squared times. So because of this, here the time complexity will be O(n) square. So let's now talk about another nested loop, but here the loops are dependent. So here you can see the outer loop runs from 0 to n, but the inner loop runs from 0 to I. So that means whenever the outer loop I is 0, inner loop will run 0 times. Whenever the outer loop I is 1, the inner loop will run 1 times. And whenever the outer loop is 2, the inner loop will run 2 times. So you can see this forms a series of numbers. So here we have the series. So first of all we have 1, then 2, then 3, and so on. And at the end we have n minus 1 times. Now if we calculate the sum, so the sum will be n times n minus 1 by 2. Now if we calculate the time complexity, so it will be O(n) square. So because the sum of the series is proportional to this n square. So let's now talk about this loop. So the loop with this summing condition. So here we have this while loop. Now inside the while loop we have this summing condition. So we are calculating the p by adding the sum of I in every iteration. So here the loop will increment the I and it will add it to the p in each iteration. So when the p is greater than n, the loop stops. The value of this p after k iteration is, so if we calculate the sum, so it will be, first of all we have 1, then 2, then 3, and so on until k. Now here if we simplify this, it will be k times k plus 1 by 2. So the loop will end when this value is greater than n, or we can say that k is approximately square root of n. So because of this, the time complexity will be O of root n. So here we have another example loop. So here we have two nested loops. So the outer loop runs for n times and the inner loop will start from I plus 1 till the n. So here in every iteration the inner loop will run less number of times. So whenever the outer loop I is 0, the inner loop will run n minus 1 times. So whenever I is 1, the inner loop will run n minus 2 times. So this way in every iteration the inner loop runs less number of times. So you can see here it creates one series of numbers. So here the number of series is, first of all we have n minus 1 plus n minus 2 plus dot 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 so on, and at the end we have 1. So this is the series. Now if we add this series, we are gonna get n into n minus 1 by 2. So here the time complexity will be O of n square. So this way we can analyze the time complexity of different loops. So hope you understand the concept. See you in the next one. Take care.